Alright, welcome back to another video. In this one we're going to talk about GitLab continuous integration and pipelines in the GitLab YAML file. So, I mentioned in the last video that Git is used to track all sorts of changes that are being made to a repository of code, and that it's supposed to kind of give you the ability to define by your commits different versions of a code repository, of a code base. And the thing is, if you and a bunch of other developers are making changes to a code base, it's a pretty expected thing for some of your changes to conflict with one another in weird ways, or interact with one another in weird ways and introduce bugs. For even just your own changes in isolation to break sort of standard tests. And sometimes testing is sort of left to individual developers. You're supposed to run unit tests, but it's kind of nice to have unit testing be automated as much as possible. And GitLab in particular, I'm going to talk about in this video, has some really nice features for automating unit testing, and not just unit testing, but in fact you can use this so-called continuous integration, continuous deployment, CI/CD features, these features that GitLab offers, to do both unit testing and all sorts of really cool automated features. Sort of automated validation and deployment of your applications and things like that. So let's go through a little bit of a crash course on that. So if I look at my setbench repository at the commits in my repository, the commit history. So here I'm looking at the GitLab web interface, not at GitKraken. So here I see my various commits. Some of the larger commit names that don't have like header names are all the expanded descriptions are hidden, so these don't appear to have names, even though really they do. But you can see all these different commits, and you notice there's something funny here on the right. There are these check marks, and some of them have X's, and some of them have nothing. So what are these things? Well, these are continuous integration test pipeline results. So this says the commit passed, and this says the commit failed. Well, what does this mean? If I go to a passed commit, I click on that, I see here pipeline number, blah, 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 passed with stages, check in 3 minutes and 47 seconds. I mouse over this. This is the build stage that passed. This is the test stage that passed. So if I click the build stage, you can see it says compile microbench, and the test says test microbench IS tree throughput. So I can click on this, and it shows me some output. What is this output? This is actually the output of some build command. So if you look at what it's doing, it's running on some GitLab runner. This is a system that runs continuous integration, our continuous integration script. Here's what the runner is called. It's called Blitzcrank. It has some special code. It's using a particular executor. It's using the shell executor. It's running on a particular server called Scuttle. It's doing essentially a Git clone. It's pulling the information about the setbench repository, this particular commit, down onto this Scuttle machine, and then it's running DOS to Unix to just like change the line endings of files to avoid. I do some Windows development as well, I never know if my line endings that I committed to the repository are going to be CLRF line endings like \r\n, or if they're going to be just \n. And since I'm running on Linux systems, I want them to be in the Unix file endings. So I run DOS to Unix on everything, all the shell scripts. And then you have chmod to make sure the shell scripts are runnable, and then you're cding to a directory and running compile.sh. And here's the output of that compilation command. And all of this, all of these commands returned, especially the last command, returned a return value of 0, meaning that they succeeded. And so, consequently, this job in this pipeline, the build job, succeeded. And then if I look at the test pipeline, the test job in the pipeline, so the test job looks fairly similar at the beginning. It pulls the information from the Git repository down onto the system, and then it says it's downloading artifacts. What are these artifacts that are being downloaded? Downloading artifacts from the coordinator. So these two different jobs in the GitLab pipeline are being executed kind of independently, and any outputs of one job in the pipeline are just deleted before the next job in the pipeline is run. And all of the compiled binaries are outputs of the first build job in the pipeline. And we don't want those to be deleted. They will be deleted. So what happens is we actually specify those as artifacts of the first job in the pipeline, which means they should be saved and made available to subsequent jobs in the pipeline. So those artifacts are actually the binaries that were built by the first job in the pipeline. And then again, we're running DOS to Unix to make sure our shell scripts are runnable, chmod, for the same purpose. And then we're doing a bunch of like shell commands, ultimately culminating in us running a command, a micro benchmark command, and the result is being saved to a file, and it's also T causes the results of this command. So this command is run, and its standard out is piped. Standard out and its standard error are piped to this program T. T causes all of that information to be printed to this file and also to the console. So it just shows everything that was output by this command on the console. It also saves it to a file. So here's the output of running that command. This is just like a standard run in the setbench benchmark, and it's just trying to see that this thing actually runs and produces sensible output. And this is just a super trivial check. Only just started preparing continuous integration stuff for this repository. So this is a super simple check. We just run one data structure test, and then we use command line tools to fetch the throughput from this output and just verify that the throughput, exists. We just print it. That's it. Very simple test. So how does this stuff get run? What is this pipeline? How does this get triggered? How does this testing get triggered? Well, the way that this testing gets triggered is every time I push anything to the setbench repository, these tests, which are defined somewhere, get run. They get executed, and the commit that I've pushed gets either an X or a check. By the way, what does it look like when you have an X here? In this case, the build stage passed and the test stage failed, so I can click on the test stage here to see what happened. And you can see the command got executed, and at the end there's a PAPI error. The event does not exist. This is because it turns out this test is being run inside a virtual machine, and PAPI events like level 2 cache misses cannot be accessed from within the virtual machine. The virtual machine doesn't have access to the performance monitoring units of the hardware. Why didn't this happen in subsequent runs? Well, I disabled these tests if you're running in a VM environment. So this is my own little CI bug, continuous integration bug, that I ended up fixing. Okay, so that's what a failed continuous integration run looks like. By the way, the reason it failed is because my program that I ran, the last command that I ran, had exit status non-zero. A non-zero exit status on the last command in a job means that that job will be considered to have failed according to GitLab. And if any job fails, the pipeline stops at that failed job. Okay, so how are these jobs actually defined? Well, here I have the repository downloaded. If I list the contents of this directory, you can see this gitlab-ci.yaml file. So there's a gitlab ci YAML file. This is where you actually define what should happen, what sort of continuous integration actions should be taken, how many stages your pipeline should have, what jobs should be in those stages, what should happen during each of those jobs. So I can just open that file up in a text editor, and you can see what that file looks like. So the first thing you do is you define your stages. This is how you do this. So I wanted only 2 stages just to start for this project, build and test. And then there's this before script section. This is any commands that you want to run before every job in every stage. You just always want to make sure your DOS to Unix line endings and all the appropriate files are chmodded appropriately. This is just run before any job. and then you start to specify your actual job. So here's one job, compile microbench. It belongs to the stage build. The script section of code is what you actually want to be executed. These are bash commands, just with a dash in front, dash space in front. And you can see down here, this script section is quite a complicated thing. I'm sort of leaning away from doing these complicated things in the script section and just having a shell script, which is more easily updated. It's easier to debug a shell script than it is to debug all the commands in this YAML file, because I can debug the shell script by just modifying it and rerunning it. To get these commands in the YAML file to run, I have to commit and push this thing again, and then see if this thing succeeds or fails on GitLab's end. So it's sort of nasty debugging YAML files. So it's nice to make these sort of script sections as simple as possible. Just have it run a shell script. That's what I'd recommend. I'm eventually going to change this. This was just, I was a newbie to CI, or more of a newbie than I am now. I still sort of am one when I designed this. Okay, but here in the compile microbench, the script is just go to the correct folder and run the compile shell script. And then you have these artifacts that are produced. So the artifacts that we're going to consider to have been produced by this compile microbench job is everything in all of the subdirectories recursively of these paths. Just this path in particular, microbench/bin. So everything in microbench/bin and everything in every subfolder of microbench/bin, which is just a binary folder. This is where all our binaries go. The fact that we specify this artifacts means that these won't get deleted before we run this job. Or more accurately, these will get uploaded to some central location. And then everything, at the end of this job, everything that this job created on the disk will be blown away. And when we start this job, a new copy of the repository will be pulled, and these artifacts will also be pulled. So in the test job, which is part of the test stage, when we try to run these binaries, microbench/bin/whatever, they will actually exist. So that's a quick crash course in the YAML file. If you have this YAML file in the root of your repository, then when you commit and push to your repository, all of the jobs and stages defined in this YAML file will all be executed, and you'll get these check marks or X's. And if you want to sort of, be able to, make these things fail intentionally when undesirable things happen, you just have to remember that a non-zero exit status from a given job means that that thing failed. So if you ever, return 1, as part of the script, or as, you can return 1 from your, if you only have one shell script that's run as part of your script block, the last thing that happens in the script block is just a shell script that does all your work. Anytime you return from this shell script with a non-zero exit status, that job will fail. So you can kind of return 0 from the shell script if you want, if you've deemed this thing to be a success, and 1 if you've deemed this thing to be a failure, and you'll get the appropriate check marks or X's as you desire. Okay, but then where do these things actually run? So if I go to the settings for my repository and I go to CI/CD, continuous integration, continuous deployment, you can see that there are runners where your this stuff has to run somewhere, right? There has to be a server where this runs. Runners is where you define the servers where this will run. So you have two options. You can use the shared runners. GitLab provides for you shared runners that you can use for free. You get up to 2,000 minutes per month, continuous integration minutes per month. So you can use those, and then at some point you might just run out of minutes. Or you could pay for the premium service and get more minutes. Or you can set up a specific runner on your own to run your stuff. So this basically means you can fire up a VM on your own system, for example, and make it publicly reachable, install their GitLab runner and set it up, and then you can actually see your own custom runners that you can enable for your project here. So, and then if you want, you can do what I did and disable the shared runners so it'll only run on your own server. Okay, so that's a crash course in GitLab continuous integration and continuous deployment. Thanks for watching.